All right, guys, Mr. Antonucci here, and in this video, I want to talk to you about how to classify real numbers. So when we're talking about real numbers, you can basically divide real numbers up into two main groups, positive numbers and negative numbers. Positive numbers are all those numbers greater than zero or to the right of zero on the number line, and negative is the opposite. They're every number less than zero or to the left of zero on the number line. The only other exception to that is zero itself, which is neither positive nor negative. Now, natural numbers are the numbers that you naturally count with. So like 1, 2, 3, 4, and so on. The next set is the whole numbers. They're exactly the same set of numbers as natural numbers, except they include zeros. So 0, 1, 2, 3, and so forth. The next set is integers. And those include all the whole numbers and their opposites. So now we're getting to negatives. So -2, -1, 0, 1, 2. But no decimals or fractions or square roots or anything like that. Now, rational numbers are numbers that can be expressed as a fraction a over b, where b is not equal to 0. Okay, so 3/4, 2/5, 17/9, those types of numbers. Now, all natural, whole, and integers can be expressed as rational numbers by just placing them over 1 or having an equivalent expression that reduces to a natural, whole, or integer number. Rational numbers, if you express them as a decimal, will either terminate or they will repeat. So they're decimals that repeat or terminate. Now, the other set of numbers is irrational numbers. Irrational numbers are numbers that cannot be expressed as a rational number. In other words, you can't put it as a fraction where the numerator and denominator are both integers. So irrational numbers would be like square root of 2, pi. Maybe you've heard of the number e. Maybe not. That's okay. And then real numbers is the set of all of the numbers. Now, there's this handy chart here that describes or shows the relationship. Natural number is the most restrictive set of numbers. Remember, that was 1, 2, 3, 4. Whole numbers contains all the natural numbers and 0, so it's a little bit bigger. That's why you see natural inside of wholes. Integers is a little bit bigger. It contains all the whole and natural numbers and all the negatives of those numbers. Then rational numbers contains all of those numbers and all of the fractions as well. Then irrational numbers are kind of like unique. They are all the numbers that don't fit into rational numbers. And then real numbers is everything put together. Okay, so here's a couple examples. We want to name all the sets of numbers to which each real number belongs. So 5/23 would be a rational number. And it's also a real number because all rational numbers are inside of the real numbers, but it's not an integer because 5/23 does not reduce to a whole number or a natural number or an integer. If you convert it to a decimal, 5/23 would be 0.217391303 on the calculator. Now, the calculator can only go out so many decimal places, and that's as far as it goes. But if you could go further, you would see that the decimal would either repeat a chunk of those numbers continuously, or it would just stop. Okay. The next one that we want to look at is square root of 64. Now, square root of 64, you might be tempted to say that that is an irrational number because it has a square root, but 64 is a perfect square and it simplifies to 8. 8 is a natural number. I'm going to abbreviate. It's also a whole number. It's also an integer. It's also a rational number. And it's also a real number. So 8 actually fits all of the sets except irrational numbers, because natural number is 1, 2, 3, 4, 5, 6, 7, 8. Whole numbers, all those including 0, which that fits, and then integer, rational, real. Now, the next one is square root of 63. Square root of 63 is not a perfect square. And if you take the square root of a number that's not a perfect square, it It will be a decimal that doesn't terminate and doesn't end. Or excuse me, it doesn't terminate, so it doesn't end, and it doesn't repeat. So this is an irrational number, and all irrational numbers are also real numbers. Okay, so you want to see what set inside it fits, and then all the ones outside of that, the numbers will fit in. Okay, so that's it for classifying real numbers. Hope that was helpful to you. Take care.